Hello, my dear students, and welcome to our Mathematics 10 session with me, your teacher, Mr. Pineda. Today, you will revisit the operations on integers. Operations on integers. Before we start with the operations, let us have the absolute value first. And here is the definition of the absolute value. In geometry, the absolute value of a real number is the distance of such real number from zero along the real number line. Let us have this number line here. So you have already learned that a number line is divided into two equal halves by a zero, while on the right side of the zero are those positive real numbers. So starting with 1, 2, 3, 4, and so on. So this arrowhead suggests that the list of positive real numbers extends infinitely to that particular side of the number line. While on the left side of the zero, we have those negative real numbers, starting with -1, -2, -3, -4, and so on. So again, this arrowhead suggests that the list of the negative real numbers extends infinitely to this side of the number line. Suppose that we wish to know the absolute value of a certain integer. An absolute value is usually denoted by two vertical lines like this, while we write the integer between those two vertical lines. Suppose that we wish to know the absolute value of 5, we are writing the 5 between those two vertical lines. And we are reading this as the absolute value of 5. So based on the definition of the absolute value, so we have to locate first the positive 5 on our number line. So 5, and here is our positive 5. So next, let us locate the 0 here. And now we merely have to count the number of unit distance between the 0 and the positive 5. So counting from 0, we have 1, 2, 3, 4, and 5. So we have a total of 5 unit distance from 0 to that integer 5. So that means the absolute value of 5 is equal to 5. And let us have another example. So let's say that we wish to know the absolute value of -5. So we merely have to look at the location of the -5. So the -5 is somewhere here. And counting the number of unit distance between 0 and -5, we have 1, 2, 3, 4, and 5. So the answer here will be 5. So notice that since that we do not have any concept of negative distance, we are writing the distance between the 0 and the -5 to be equal to 5. So you might have already noticed that we can come up with these values easily. Let's say that we have another example of the absolute value of -10. So this will only give us a value of 10, while the absolute value of 7 gives us 7. So let us proceed with the operations on integers, starting with the addition of integers. So the addition of integers has two categories, and one is the addition of the integers with like signs. And to start with the addition of integers having like signs, then our rule will be to add the absolute value of each integer and affix the same sign. So to fully understand what do we mean by such rule, let us have these examples. So let us have the first example. We have a 12 plus 39. So since the definition talks about the absolute value, let us identify first the absolute values of those given integers. So having this to have an absolute value of 12, which is equal to 12, while this one has the absolute value of 39, which happens to be equal to 39, then, based on this rule, we must add those absolute values. Since these absolute values are those exact integers right here, let us add these integers directly. So having this to be equal to 11, while this one we have a total of 5. So the answer here will be 51. But let us check whether we have the correct sign for this. So based on the rule, we have to copy or affix the same or common sign. Since both of these integers have a positive sign, therefore our sum will also have a positive sign. And now for the second example, we have a negative 26 plus negative 38. So looking at the absolute value first of those integers, starting with the absolute value of negative 26, which happens to be 26, while the absolute value of negative 38, which is equal to 38, then based on the rule, we have to directly add those absolute values. So performing the addition, we have this to be equal to 14, while this have a total of 6. And looking at the integers, the original integers have the same negative sign. So we have here a negative for the 26 and we have here a negative for this 38. So the common sign is negative. So for our final answer, we have a negative 64. And let us have the third example. So let us have the absolute values of these integers directly. So instead of having the negative 115, the absolute value is 115. So this is negative 58, the absolute value is 58. Adding these absolute values gives us a total of 173. And since that both of these integers have a negative sign, then the final answer will also have a negative sign. So again, for our answers, in number 1, we have a 51. For number 2, we have a negative 64. While for number 3, we have negative 173. And now let us proceed with the addition of integers with unlike signs. So here we have a different rule for which we have to subtract the smaller absolute value from the larger absolute value, and we need to affix the sign of the integer with the larger absolute value. So let us take a look at our first example. So here we have a negative 32 plus 19. So notice that the first integer is negative while the other one is positive. So they have different signs. And now let us try to add these two integers. So going back with our rule, we instead perform subtraction. And what do we need to subtract are the absolute values of those numbers. So here we have to write first the larger absolute value, which is taken from the negative 32, whose absolute value is positive 32. And we need to subtract the smaller absolute value. And this is obviously the absolute value of 19, which is equal to 19. And now we have this to be equal to 13. So going back to this particular statement about the rule, we need to affix the sign of the integer with a larger absolute value. So obviously, the negative 32 has the larger absolute value, which happens to be positive 32. While originally, it has a negative sign, so the answer also has a negative sign. So here, the final answer would be negative 13. And let us have the next. So we have the 46, whose absolute value is 46. And we have a negative 38, whose absolute value is 38. So we must perform a subtraction. So here we have, so this only gives us 8. While going back to this values, obviously 46 has the larger absolute value, which is 46. And originally it is positive. So the final answer will also be positive. And that would be positive 8. And let us take a look at the third one. So here the larger absolute value will be from the negative 128, whose absolute value is 128, while the other absolute value is 57. So again, we need to perform a subtraction. And this gives us 71. While for our final answer, we have to go back with these two original numbers. The higher absolute value is 128, but originally it has a negative sign. Therefore, our final answer would be negative 71.